My name is Andrei Kvapil. Let's talk about Cozystack. How many of you already heard about the Cozystack? Please raise your hand. Thank you. Cozystack is CNCF sandbox project starting from March 2025. We built next generation cloud platform which is fully based on Kubernetes. Cozystack is focused on providing managed services, not only virtual machines. Nowadays, we say nobody needs just pure virtual machines, and everybody is looking for fully managed and fully controlled managed services like you have in cloud. Cozystack provides ready infrastructure stack with minimum dependencies, just like external storage system. And you can also consider Cozystack as a framework which you can use to build a platform and provide your own managed services to your customers. Cozystack already includes such services like managed Kubernetes, databases, queues, virtual machines, persistent volumes, and S3 storage. Talking about Kubernetes, managed Kubernetes service, we usually say that it works pretty similar like in every cloud. So we have control plane separated, users have no access to their control plane nodes, and provide all the features like load balancers, persistent volumes, and cluster autoscaling. Cozystack focused at bare metal at most, because bare metal is faster, cheaper, and sovereign. With bare metal you have predictable costs, and your data, your rules, which is perfect for AI, regulated, and edge workloads. But rebuilding cloud-like experience on bare metal is hard, not with the Cozy. You can take just a bunch of your servers, install the platform on it, and get a ready interface to ordering managed services. To make it possible, we start working on very low level. Actually, we have pre-baked image for the system, which contains already predefined kernel and kernel modules used by the system. On the layer 2, we provide storage, networking, virtualization, then some operators, cluster IP, monitoring, and on the layer 4, you have Kubernetes objects using which you can order your own managed services. You can simply install Cozystack with our installer and get this dashboard where you can install any services you want to. Every service is actually a Kubernetes YAML object, which can also be configured in user-friendly interface. Under the hood, we use KubeVirt and many other projects. Actually, KubeVirt allows us to split the workloads between the tenants, so they can't affect each other. Talking about database as a service, we fully focusing on operator approach, because only operators knows how to manage the database and can actually operate the logic correctly. With Cozystack, you can create databases, manage user rights and their access rights, configure backups, and have pre-configured monitoring dashboards and alerts. To integrate with Cozystack, after you get your cloud installed, you just need to have one YAML file to order one service, so integration is very simple. In case if you want to extend the platform, we have more interesting design to do that. So we actually build API objects out of the Helm charts. But once you wrote your Helm chart, our aggregation API server actually will extend the Kubernetes itself and will show like normal objects to your users. So they can operate normal objects like Kubernetes kinds to order virtual machines and Kubernetes clusters. Cozystack has also a very interesting tenant system. It is based on Unix, old Unix patterns when we have tenant root, and also it can be recursively give you permissions to specific Kubernetes namespaces where you deploy your workloads, but also spread specific workloads. Let's say you can have one common Grafana for all the tenants, or you can separate monitoring stack to have separated monitoring stack for each tenant. Then you can connect your tenants to specific users using integrated Keycloak, integrated OEDC server. So your users can authenticate through the GitHub, GitLab, or Google and get access to their bare metal cloud. Talking about storage system, we also focusing on provide really fast and reliable storage. So we use LinStore, which is based on proven technologies like LVM and ZFS, and we can enable replication, which works right in kernel using the RBD protocol, which is very, very fast. The interesting thing that applications and databases running right on bare metal with no virtualization overhead, but we still have virtualization for user workloads. And talking about networking stack, we use Cilium and KubeOVN. Cilium gives us a network policies and kube proxy replacement, and KubeOVN gives us permissions, give us such options like to live migrate virtual machine with persisting IP address, have VPC support, and so on. That's actually it. Please feel free to join our community, give us a star on GitHub. We have bi-weekly community meetings. Everybody is invited. Thank you.